Hi everyone, welcome back to another video. So we're still continuing through the K.A. Stroud Engineering Mathematics book, and we're on the Trigonometry chapter. So we're currently going through the Trigonometric Fundamental Identities, and in the last video we ended up here. We needed to prove that tan plus cotangent is equal to or the same as secant plus cosecant. Right, so we'll paste that in there. And then let's just write out our fundamental identities that we've got so far, right? Fundamental identities. Okay, so number one is cos squared plus sine squared is equal to 1. Number two is 1 plus tan squared is equal to secant squared. Remember that we derive each one of these from either the previous one or from the main one. Cos plus sine is equal to 1. The cotangent, if you're not sure how we derive these, go back and watch the last video. Plus 1 is equal to cosecant squared. And then the last one that we did was 1 over 1 minus cos plus 1 over 1 plus cos is equal to 2 cosecant squared. Cool. So these are the four that we've done so far. So they want us to show here that tan plus cotangent is the same as secant times cosecant. So let's just convert tangent and cotangent to get it into what we're used to in terms of sine and cosine. So tangent, you should obviously be very good at this now. Tangent is sine over cosine, and they're not squared, so we don't need to do any squaring. And then cotangent is just the inverse of tangent, right? So that means it's just cosine over sine. Again, if you're not comfortable with that, make sure go back and watch the last two videos. All right, and then to add both of these fractions to add these two fractions together, obviously we're going to multiply these two, right? And then we're going to cross multiply here and here to add together, which again we went through in the last video. Up here I gave a basic example of it here, and then we did it in all these 8 steps here. So again, go back and watch that last video if you're not comfortable with that. Alright, so this is then the same as sine multiplied by sine is just sine squared, obviously. And then we'll do the top one again. Cosine multiplied by cosine is cosine squared. And then in terms of the denominators, cosine times sine is just cos times sine, and cos times sine. Now here's where we're going to use the fundamental identity again. So sine plus cosine is equal to 1, right? The main fundamental identity that we've got there. So we can replace this whole fraction here with just 1 over cosine times sine. Why? Because here sine plus cosine is equal to 1. So we're just literally just replacing this whole bit up here with just 1. And then the denominator is staying the same. Cool. Okay. So another way of writing this fraction out would be to write, would be to write 1 over cos times 1 over sine, right? And then remember 1 over cos is secant and 1 over sine is cosecant. So we could just rewrite, for example, this as secant times cosecant, right? And then let's just stop there. Do you remember what we was trying to do? So we was trying to prove that tan plus cotangent is the same as secant times cosecant. And as you can see there, we've proved that. So we proved that in 1, 2, 3, 4, 5 steps. Okay, so let's move on. So here we just finished this part here. Try this one. That's what we just did. And then here they are walking us through it again. I'm not the biggest fan of their explanation. I ended up getting very confused the first time I went through this book. So that's why I like to work out myself. I mean, I could just walk you through that, but it gets a bit confusing. Okay, so now they're asking us here to demonstrate the validity of each of the following identities. So we've got A and B. Let's start with A first. Okay, so looking at this, we got tan squared. Obviously, we can convert that easily. Minus sine is the same as sine to the power of 4 times secant squared. So tan, let's just convert that straight away, is just sine squared over cosine squared minus sine squared. Okay, so here's an important point that we need to make, right? Which is that dividing, you know this intuitively, right? Let's just talk through it. Dividing by cosine is the same as multiplying by what? 1 over cos, right? Think about that. You know, dividing by 2 is the same as multiplying by a half. Sounds a bit basic, right? But dividing by cosine is the same as multiplying by 1 over cosine, or another way of looking at that is by multiplying by secant, right? So let's rewrite this again. We can write this as the reason why I'm doing an arrow is so that I don't confuse you with this. I'm not drawing the other side of the equation yet. I'm just converting this whole side here. That's why I'm drawing the arrows. Okay, so we can rewrite sine squared over cosine squared minus sine squared as sine squared times secant squared minus sine squared, right? Then, if you remember factorization, we can factorize out sine squared, so we can do sine squared multiplied by secant minus 1. So just take a look at that. If you multiplied out that bracket, sine squared times secant squared, and then sine squared times minus 1, that would give you that, right? Now this is where this it's not going to immediately jump out at you, but the more you do it, you'll get used to it. Secant minus 1. Let's take a look at our fundamental identities up here. Secant minus 1. So what was to happen here if we took away 1 from both sides of the second identity? You'd get tan squared is equal to secant minus 1, right? Let's do that. So just rewrite, copy this fundamental identity here. So we're going to take away 1 from each side, and that's going to leave us with tan squared is equal to secant squared minus 1, which is exactly what we've got here. So we can just rewrite this whole thing here as sine squared multiplied by tan squared. And you see where we're going with this. It's literally just, we're just rewriting. So again, you could probably do the rest from here now. Sine squared times sine squared over cosine squared. And then another way to look at this is, you know, you can put obviously anything over 1 to make it so you're just multiplying 2 fractions. Sine squared over 1 times sine squared over cosine squared. And then you just obviously multiply across fractions, right? So sine squared times sine squared is equal to sine over 4. Sorry, sine to the power of 4. And then 1 times cosine squared is equal to cosine squared. And then remember again, what did we say here? Dividing by cosine is the same as multiplying by 1 over cosine or secant. So we can rewrite this whole thing here as sine to the power of 4 times 1 over cosine squared, or finally sine to the power of 4 times secant squared. And so we can stop here. So let's go back and see, did we fulfill what we wanted? Did we prove it? Tan squared minus sine squared is the same as sine to the power of 4 times secant squared, and that's exactly what we proved here, right? How many steps? That obviously took a lot more steps, but it's good practice. So we did it in 1, 2, 3, and you can include this, I suppose, 4, 5, 6, 7, 8, 9, 10 steps. All right, so that one's done. So we've proved A. Now let's prove B. What was B? B was 1 plus sine theta all divided by cosine is the same as cosine divided by 1 minus sine. And I've given us some information here. They said take care with the second one. It is done by performing an operation on both sides first. Okay, so that's a nice little tip for us. Okay, don't ask why I do this. I just like to have it rewritten in my own handwriting. So let's just do that. It's the same as cosine over 1 minus. Okay, so they've told us that we need to do something to both sides. What makes sense to me is to just get rid of these fractions and just, basically multiply each side by the opposite denominator. So if I multiply both sides by the opposite denominator, what do I get? I get 1 plus sine, all of that multiplied by 1 minus sine. Right, so I've multiplied this numerator by the opposite denominator is the same as, and then just going to do the same thing, cos times cos, right? And then I can just factor that out. So 1 times 1 is 1. Sine times minus sine is minus sine squared. And then sine times 1 is plus sine. And then minus sine times 1 is minus sine. So those two cancel each other out. And then is the same as cos times cos, which is cos squared. These two cancel each other out. So you're left with 1 times minus sine squared is the same as cos squared. Okay, now from here we're done, and the reason why we're done is the question you want to ask is this here, is this valid? Let's see, is this valid? So have a think about that. The reason why it should be valid to you is if we go back to our fundamental identities. So if none of them are jumping out to you, 1 minus sine squared is the same as cosine squared. So if we added, plus sine squared to both sides, what do we get? We get 1 is the same as cos squared plus sine squared. And you could even write that as cosine squared plus sine squared is equal to 1. Now tell me, do any of them jump out to you? The obvious answer is this one, right? Cool. So yes, because it is the fundamental identity, so it is completely valid. And so you can see that we have proved both A and B. And then again, they work through this one here. And you can see they end here with, since cosine squared plus sine squared is equal to 1. Cool. Okay. So in the next video, we'll start with identities for compound angles. Again, just get comfortable with this. I suppose this is just a lot of you're just converting, basically. Replacing and converting. So just practice this one, go through and do it yourself, and you'll get comfortable with it. Cool. All right, thanks for watching, guys, and if you enjoyed it, leave a like, and I'll see you in the next one. Peace.